All right, so this is confidence intervals, p-value, or something else. And I am Lisa Ennis from the Alabama College of Osteopathic Medicine. And I think we're going to pop up a little poll here in just a few seconds to just kind of see where you're from and all of that kind of stuff. About this workshop, the scholarly snippets are a series to help you advance your research skills and support your scholarly activities. After this, you should be able to describe the difference between p-value, confidence intervals, and effect size. Now, this may be a little ambitious, but we're going to do our best to get through it. There will be no math required for this, so if math is not your thing, don't worry, we're not going to make you do any actual math. I was told there would be no math, so there we go. And so you should have a attendee type here, and this is just for our information so we can figure out how to make these snippets better for you all. And so here we go. Buckle up. This is going to be a wild ride. All right, so what we're talking about here are inferential statistics. And so when we talk about inferential statistics, we're talking about making conclusions about two or more populations, right? And we're going to draw those conclusions from a sample of that population. What we want to do is estimate some effect or difference from the sample to that larger population. Okay, but when we make this kind of inference, there is always uncertainty, right? So we can never be completely confident. All right, so when we talk about tests of significance, we're talking about two primary approaches. So we can have a p-value or a confidence interval. Now, I'm going to go ahead and tell you that when I see a paper, I want to see both, okay? But we're going to make some assumptions when we do these hypothesis testings. We're going to assume that the population is representative, or the sample is representative of the population. The individuals in the sample are individually selected, and the sample is large enough to make an inference. And usually you have to have the minimum is 30 for a sample size, right? Okay. Now, everybody talks about p-value and everybody gets really excited when they have statistical significance and their p-value is really low. But all a p-value does is tell you that the difference you're seeing is likely due to chance or not due to chance, right? So there's very restrictive statements about effective strength are possible on the basis of just a p-value. And all you're doing is rejecting or accepting a null hypothesis. So what does that mean? Okay, so a null hypothesis is the statement being tested. So the statement is no effect or difference. So a null hypothesis would be there is no difference in the population. The alternative hypothesis is there is a difference in the population. So you run the test, and the statistical test you run is going to depend on the kind of data you have, because there's more than one kind of statistical test that you can run. Okay, so what we're going to do is have a cutoff point. It's also referred to as alpha. And this cutoff point that people usually talk about is 0.5 or less is considered statistically significant, right? And if it's statistically significant, you reject the null hypothesis, right? If there's no statistical significance, then you do not reject the null hypothesis. And that's all you're doing. You're saying that something is likely due to chance or likely not due to chance. So the lower the p-value, the less likely it is that something happened by chance, but you can never disprove the null hypothesis. We're only saying whether or not there is enough evidence to support it. So p-values are kind of educated guesses, and they can't tell you if they're biased, so they have some limitations. So I have here some examples of a null hypothesis, right? So the average weight of male adolescents is the same as the average weight of female adolescents in the population, right? So the alternative hypothesis is the average weight of male adolescents is not the same as the average weight of female adolescents in the population. But this is just telling you that it's statistically significant. It's not telling you anything else. It's just that it's probably not due to chance. So when we write up the results of a p-value test, all you're saying is we have evidence that the average weight of adolescents differs by sex in that population. That's all we're saying. It doesn't tell us how much weight difference there is. It doesn't tell us this is meaningful. It just tells us if there is statistical significance. So y'all know I got problems with S's, so y'all just have to bear with me on that. Now, that's all it does. So we can go up a little bit, get a little bit more confident about things by using a confidence interval, right? So if we say a p-value is determined whether or not the null hypothesis is accepted or rejected, a confidence interval shows you the probability that if you do a test more than once, that the truth will lie within a certain range. And so I've got a picture here of how this looks. Right. So ideally, if you're doing research, you want this research to be replicable. So the confidence interval says, if I have a confidence interval of 95%, I'm going to be sure, and I do this study 100 times, that 95 times that somewhere the mean that's going to fall on that line and it's going to be the same-ish, right? But one time it's not going to work out, which is pretty interesting. But that doesn't really tell us a whole lot either, right? So a confidence interval is just going to give you a plausible range for the true value related to the measurement of the point estimate, right? The statements are possible in the direction of the effect as well as its strength. So you've got this range, and I've got an example so you can understand this a little bit better. But p-values and confidence intervals, they're not contradictory. They're kind of go together. So when I look at a study, I want to see both of those things. All right. So the usefulness of a confidence interval is because it gives you a range of values, and it can take the variation in samples into account, because no matter how careful you are to get a good sample, there's going to be some outliers in these samples. There are going to be some differences that just happen because we're dealing with people and people are messy, right? And so we want to get as near as we can, but we can never be 100% confident, right? But the confidence interval gives us a degree of certainty or uncertainty in a sampling method. They're mostly constructed using levels of 95%, or if you're really good, 99%, right? So it's just a range of values. Now here's your ridiculously simple example. If we have an average systolic BP before treatment in study A, and we have a group of hypertensive patients, and the average was 170, right, after treatment, then it drops 20 average. And if we have a 95% confidence interval, then we're going to say that if you take drug A, your blood pressure is going to improve by 15 to 25 points. And then we can be 95% confident that the true effect of that treatment is to lower BP by 15 to 25 points. Hope that makes sense. We're saving questions to the end. I know I'm going fast, but I want to hopefully get through this. So we've got that. So we got a range now. So that's a little bit better than a p-value, because a p-value just tells you if it's statistically significant without, a whole lot of explanation. It's just like, yeah, that change is likely to do with chance or not. That's it. That's all it tells you. So confidence intervals and p-values, they can the sample size matters when you calculate these things, right? So if you have a size of a confidence interval related to the sample size, larger studies generally have a narrower CI, right? Narrower confidence interval. The larger the sample, the more confident we can be. Okay, and they are calculated from that standard deviation, which show how far from each measurement is the mean of the sample. So the wider the spread, the CI is less precise, right? And you can't control the spread. The numbers are just what you get. So then if we've got a confidence interval and we've got a p-value, then we know something is statistically significant. But what we don't know is what is the real world application of this, right? Because something can be statistically significant, but does it really matter? If we have a drug and drug A is statistically significant, but out of 100 people, only 2 people benefited from it, is a real world application worth pursuing that drug, or going back and researching and make a drug that works better? It has a larger effect size. Okay, so the effect size, and you'll see this, publishers and different organizations, and the American Psychology Association is one of them, that is requiring people to include effect size, because just because something is significantly significant or statistically significant doesn't mean it's clinically significant or practically significant, right? So the effect size is going to show you the measure of the magnitude or strength of the outcome. So the larger the effect size, the stronger the relationship between those two variables, right? And so the effect size is going to show us if the effect is large enough to matter in the real world, right? So generally what we have, if you have something less than 2 of an effect size, that's we don't like that. If we have less than 5, or between 2 and 5, that's kind of getting in the medium range, and over 5 of an effect size is where you can really get a larger, this is meaningful for the real world people, right? So when we talk about effect size, we're talking about, does it matter in the real world? Because you can run tests of significance for all kinds of things, right? Statistical significance. And I've got a copy here of just a couple of things. This website is a whole lot of fun. This is Superlius correlations. And so this fellow, and he's got a reputable source right there. This is from the U.S. Department of Agriculture and National Science Foundation. And there is significance, statistical significance, if you compare the per capita consumption of mozzarella cheese, and it correlates with the civil engineering doctorates awarded, right? So you can get all kinds of, but does that matter? Does that matter? Is that even important? No, that's not really important. We don't even care about that. And then here's another one over here that I thought was pretty cool. So we found a correlation in the data, so everybody's going to get a razor and shave their head, so the sales will go up. Right. So now what you want to see is, you want to see the p-value, you want to see the confidence interval, because those are important pieces. But now we're adding the effect size, which gives it that real world practical application. Is this worth pursuing? Is this going to be meaningful for people? And the thing about effect size and all these statistics is, depending on what kind of variables and what you're measuring, you use a different formula. And there are several formulas for calculating the effect size, which are really interesting, but I said there would be no math. So I know that was really fast, but I think I may have gone too fast. So if there are questions, I can answer questions, or we can talk about something else. Everybody's hair blown back, you falling on the floor. It's a lot. But the main takeaway is that all a p-value tells you is if there is a statistical significance that is likely or not likely due to chance. The confidence interval is a range of values around what the researcher thinks the truth is. And then the effect size is what will give us a notion of, does this actually matter in the real world? Yeah, they'll post it. And we can, if you're interested in more little stat pearls, we can definitely let us know, and we can do some more of those. The math is not the strong point for me either, but knowing what the numbers mean is so important when you're critically evaluating an article. So if they're just reporting statistical significance, you should look deeper, and especially if they don't include a confidence interval, or if it's just a p-value, it's like, but does this matter? I want to see all three. So that's one of the things about, so the question is about studies with with a larger sample size can be closer to the truth in the real world. So sample size matters less with effect size. And some people say it doesn't matter at all when you're calculating effect size. But p-value, if the larger the sample when you're calculating p-value, the more likely it is to be statistically significant. So if you have a small sample, your statistical significance may not show up. It may show up as not statistically significant. But then if you did the same study with more people, there you go. If you did the same thing with more people, then it could be statistically significant, because it's all the math can be done in so many ways. And so if you get into, well, did they even choose the right test to get statistical significance, then yikes, you really have to evaluate stuff closely. But if I don't see those three things, I get a little suspicious, and I want to look closer. Yes. So it not only does it change with disciplines, it changes with the variable types, and it changes with like if you're doing a drug study, that's different. If you're doing like a public health intervention, then that's a different test of effect size. Yeah, so I think my personal impression is that folks are really focused still on the p-value and the confidence intervals, right? But the APA is really pushing for all three, and they're coming down on requiring you to do all three, and not even just say that you had a good effect size, but really explain why that's important and how that works. But yeah, so and each like discipline and things like that too, if you're dealing with ordinal variables, that's different. If you're numeral number values, those kinds of things, the test can be different. Let's see. Oh, so it's on the slide. If you Google spurious correlations, you get this, and his links down there, so you can see I've got a little, for some reason this is translating what I say over my link there, so I can't see it, but his name's Tyler. Yeah, he's awesome. There's a lot of cool correlations he makes based on like actual real data. That's it. Thank you. We call these, yeah, it takes time. It takes time for people to change. If they don't include a sample size calculation, then I'm really suspicious. The sample size is very important. And if we do one of these on type 1 and type 2 errors, you'll know the only way to increase the power of a study is to increase the sample size. And that helps with both of those. So if we wanted to do a type 1, type 2 error one, we can definitely do that. Just make sure you let folks know that that's of interest in the evaluation, because we have a little evaluation. I got some references here that, you know, you can pause it when it's posted and take a look at those on effect size. Some really good videos out there too on effect size and how it works. And if you want to look at the math, there's plenty of them out there with the math. And then we've got, you know, a survey here. So we wanted to know how we did, and you can put any other topics, like any other statistical topics you want in there if you want to look at any of these closer. And then the next workshop's on the 24th on data visualization. I'm really excited about that because I'm really into data visualization right now. They say a picture's worth 1,000 words, right? Any other questions? Let's see. Katie, can you pop the link in there for the
yeah, copy and paste it now.
Yeah. Yep. Cool.
Are there any questions in the chat that were not answered? I want to make sure that we have to address all of those. Nothing got missed.
Yeah, so if there are no other questions, we appreciate you taking the time to visit with us today, and please do the survey and let us know what you thought. And if you want more statistics, and May the 4th and the 5th be with you. We've got just a few days left to Kenobi, for Kenobi to come out there, for all my Star Wars friends out there. I can't wait. This is the way, right? This is the way. Yep.